In exercise 2K, we're using simultaneous equations to solve problems. So what we have to do is we actually have to write a pair of simultaneous equations from the question. And then we have to solve it simultaneously. We can choose to use substitution or elimination. And it really depends if the equations look the same as the last exercise on elimination, or if the equations look the same as the exercise before that on substitution. So here's our first example. The sum of two numbers is 12. One number is 8 more than the other. What are the numbers? So I'm just going to call my numbers x and y. Let the numbers be x and y. Now it really doesn't matter which one's which, because there's nothing to say one is specifically the other. The sum means to add. So the sum of the two numbers is 12, equals 12. One number is 8 more than the other. So one of the numbers, I'll choose x, is the other number plus 8, 8 more than y. Now this is nicely set up for the substitution method. We can put y plus 8 instead of x. So let's write the first equation again, but instead of x, we'll put y plus 8. So y plus 8 plus y equals 12. Collect up the like terms. So we've got a y plus a y, which is a 2y, plus 8 equals 12. We'll minus the 8. So we've got 2y plus 0 equals 4. And we'll divide by the 2. They'll cancel. So y equals 2. So we've found y. We now also have to find x. Let's put it back into this one because that's the easier one. X equals 2 plus 8. So that equals 10. And we'll check it back in our first equation. So our first equation was that x plus y equals 12. X is 10, y is 2. 10 plus 2 does equal 12, so we're really happy there. Let's look at a second example. This one's a little bit harder. A total of 50 adults and children attended an event. So I'm going to call the adults A and the children C. And there were 50 of them altogether, adults and children. So if I do the adults plus the children, I'm going to get 50. Adult tickets were $5 and the child tickets were $3. The total income was $190. So let's have a look there. Any income from the adult tickets would be $5 times the number of adults. So that gives us 5A. Any income from the children's tickets would be $3 times the number of children, so 3 times C. And that equals $190. Now this is really well set up for the elimination method. I could times that first equation by 5 so that the 5A's match, or I could times it by 3 so that the 3C's match. It really doesn't matter which one you do. I am going to do the times 3 because that number is a lot. 3 times 50 is quite close to 190, so I think that'll work quite nicely. So the first equation times 3. So 3 times A is 3A, 3 times C is 3C, 50 times 3 is 150. Now we have to think, do we want to add or subtract to get rid of the 3C's? I could go 3 plus 3 or 3 minus 3. Minusing will get us our 0, which is what we want. So let's minus. So 5A minus 3A is 2A. 3C minus 3C, that's 0. And 190 minus 150 equals 40. Let's divide by the 2. So they cancel. So A, 40 divided by 2 is 20, 20 adults. And remember, adults plus children made 50 people, so the children must be 30. 20 plus C equals 50, minus off the 20. So C equals 30, 30 children. Let's check that with the income equation. So our income equation was 5A plus 3C equals 190. Let's check it. So we said there were 20 adults. So 5 times 20 and 3 times 30 children. I didn't put in brackets like I've been doing. That's the same thing though. So 5 times 20 is 100. 3 times 30 is 90. And that equals 190. So we've got it right. And there are the questions to do from that exercise.